guys, it's Elliot from tutorialedge.net and welcome to the 11th tutorial in my Programming 2D Pong with OpenGL and LWJGL 3 tutorial series. In this tutorial we'll be covering very simple axis aligned bounding box collision detection, or AABB collision detection as it is more commonly known, and we're also going to be getting our ball moving so that we can check to see if our collision detection works. Okay, so I want to begin by getting the ball in our game moving around on the screen. And this is relatively simple now that we've seen how to do it in the last video, in which we got our paddles moving. The only difference here though is we want our ball to move without us pressing any buttons. So we're going to be creating a new vector3f movement variable at the top of our class that will basically add to our ball all the time. Okay, so to get us started, right up at the top of our ball class we're going to want to create two new floating variables, and these are going to be public float width equals 0.05f and public float height equals 0.05f. Okay, and within our vertices float array we're going to change these to use in the new variables. And width here. Okay, and we're also going to be creating a movement vector, so public vector3f movement, and if we come down to our constructor we're going to initialize this, so this dot movement equals new vector3f, and we're going to start it off with 0.02f, 0.015f and 0.0f. Okay, so this is going to get our ball moving up and to the right initially, and just in our update method we are going to want to do the following: if not check bounds, and we're going to want to do this dot position dot translate movement, and we're going to create the check bounds boolean method first. Okay, and we're going to just return false initially. Okay, we're also going to create this translate method, so hover over this dot translate as it will show an error and select create translate vector3f and type vector3f, and this should add a new method to our vector3f class within our utils. And just within here we're going to want to do the following, so this dot x equals, and we're going to do this as vec, this dot x equals vec dot x plus equals, sorry, vec dot x, this dot y plus equals vec dot y, and this dot z plus equals vec dot z. Okay, notice that tidies it up a wee bit. Okay, so once you build that, you'll notice that our ball flies up and to the right of our screen. So we're going to want to change that so that it can't leave the game window, and we're going to do that by changing our check bounds method. So come into here and we're going to create 4 different if conditionals, and the first one is going to be if position dot y is less than or equal to negative 1.0f, then we want to print below the window, or below game window. Okay, and we're going to want to set our position dot y equal to negative 0.99f, so just below the boundary, and we're going to want to change movement dot y, and we're going to want to multiply that by negative 1.0f, as this will reverse the direction of our ball, and we're going to want to do mod return true. Okay, so we're going to copy and paste this 4 different times, 4, and we're going to change this to position.y plus height is greater than or equal to 1, then it's going to be above the game window, and we're going to set that to just below the game window so it doesn't stick, and we're again going to multiply the movement.y vector by negative 0.1. Okay, so next thing we're going to do is position.x plus width, and if that's greater than 1.0f, then it's to far right of the game window. And again, we're going to change these to position.x and movement.x. I'm going to change this to 0.99, and we're going to do the same again down here. And to far left of game window. Okay, so if we try that now, it gets stuck. And why is that? Position.x plus width. Because I've not done this. Minus width. And we're going to want to do minus height up here as well. So just where you've set the positions after it's collided, you want to set it to 0.99f minus the width and 0.99f minus the height for when it goes above the window. And you should notice that works now, and it collides with the boxes, the sides of the game window as expected. Okay, so now that we've got our ball moving and colliding with the game window's walls, we can start on our AABB collision detection system that will ensure our paddles can prevent the ball from hitting their own side. So to get started, we are going to go into our level class, and just above our update we are going to do the following. So public void check collision, we're going to pass in the paddle, and this the code for AABB collision detection can be found on one of my tutorials on my main site, tutorialedge.net, so you can check that out if you need a more in-depth look at it. But basically we're going to be doing something similar to this, and to get started we're going to want to do if paddle.position.x is less than ball.position.x plus ball.width and ball 1, sorry. Paddle.position.x plus paddle.width, then we'll have to create that. It's greater than ball 1.position.x and paddle.position.y is less than ball 1.position.y plus ball.height and paddle.position.y plus paddle.height is greater than ball.position ball 1, sorry, dot y. Okay, so if this happens, then we want to do a system out, and we're going to do collision detection just to get started. So call collision detected. Okay, and we're going to have to go into the paddle class and create our width and height variables. So right at the top for paddle class, public float width equals 0.05f and public float height equals 0.025f, 0.25f, yeah. And in our vertices array, we're just going to quickly change this to height, got a semicolon, and height again, and then width and width. Okay, so that sorts our error here, and next thing we're going to want to do is check collision player 1 and check collision player 2. Okay, so the next thing we're going to want to do is, within our check collision, we're going to want to set the ball's movement vector to equal, or times equals negative 1.0f, and this will, or movement dot y, sorry, oh no, x, that's x, And this will basically mean that every time our ball collides with one of our paddles, it'll be sent back in the opposite direction. And that's exactly what we want. And you see that it collided there. So that's us done with AABB collision detection. All that's really left is to tidy up a few things of the game and make it so that one player either wins or loses every time the ball hits their side. And we're going to be doing that in the next tutorial. So as always guys, if you found this tutorial useful, then please leave a like and subscribe to my channel for more game development based tutorials. Cheers.